Okay, so the formula that we were using, my students already have this written down. It's A equals P times 1 plus R to the T. This is our most basic compound interest formula. And once again, the A is equal to the final amount in the account. The final amount. P is equal to my principal, or principal, P-R-I-N-C-P-L-E. This is the amount of money we start with. R is equal to my rate, and that rate always has to be in a decimal form. And T is equal to my time. And we have our time in years. So we talked about what would happen if we wanted to see how much money we would be able to save over a certain amount of time. So we had already done this for $100 a month in our 20s, but now we're going to change it. So let's talk about what happens if we save $200 a month. That looks like one word, a month. Now I can't spell month. We save $200 a month for 10 years. So we take our 200 multiplied by 12. That's giving me what? 200 times 12 is giving me my $2,400. And then we multiply that by our 10 years. So we're at $24,000. So this isn't taking into account all of the interest that you would accrue. Think of it this way. If you get 24, like say something happens, you get an inheritance, you get a big bonus. Some of you are going to have fabulous jobs that give you a huge bonus. If you save your bonus, if you take this bonus and put it away, this is what's going to happen to that bonus. So we want to know the amount. If we start with $24,000, I'm going to use the same rate from the video. Our average stock exchange increase, especially over a longer period of time, is 12%. So I'm going to change this to 0.0, bless you, 12. And it's going to be to however many years we want. So I'm going to have A equals 24,000. I can add these together and get 1.12. And let's see how much we would have after 10 years. So this is our number of years, and this is our A, or our final amount. I can also put this in T years. So if at 0 years we have $24,000, after 10 years, do you guys get 74,540? Well, we're just starting to add the interest at that point. So we're lumping. You're right. We're at 30 years old. We have that much money. At 30 years old, or however, when you save in your 20s, you're going to have $24,000. But in terms of our equation, Renee, what we're doing is we're starting to add interest to that money. So after 10 years of interest, without adding any more money in there, our $24,000 is going to turn into $74,000. If I change that 10 to a 20, so it turns into $231,511. So almost $250,000. If I change that 20 to a 30, I'm at $719,038. So if you save in your 20s, the end of your 30s, you're going to be here, into 40s, into your 50s. So most of you will not retire at 60. You could. That's a pretty good chunk of change, $719,000. I know that have you ever, what's it called that you get from the government? Your Social Security, right? Everybody pays into Social Security. I don't think my Social Security, I can collect it until I'm like 67. I think I have to be 67 years old before I can collect Social Security. My mom was able to collect Social Security at 62. So I'm guessing you guys aren't going to be able to collect Social Security until you are at 73, 72, somewhere. You know, it's going to be in your 70s. If there's a Social Security left by the time you get there, it's going to be well into your 70s. So you're going to have a gap. You're going to have money to fill in that gap. Say you continue to work. Say you even work 5 more years. Let's go from 30 to 35. If you change that 30, that 5 more years of leaving that money alone is going to take us what? To $1,267,190. Actually, it rounds up to 91. So even leaving that money in there for 5 more years is going to change it to $1,267,000. I've run out of room, but if I do the exact same thing and change that 35 to 40, after 40 years, what are we at? 2 million. 2 million. So what you need to understand is that what happens is the longer you leave it in there, the faster, you know, like as you get older, it starts exploding. It went from 1 million to 2 million, over 2 million in just 5 years. But it's not in the beginning. It's in the end. Even more importantly, let's talk about reality, what most people do. This is what most people do. Most people don't even think about saving for retirement until they're 50. Most people are like, I don't need to worry about that. I'll worry about that later. Most people don't even, I mean, they say, it's not something I need to worry about. I'll be old, I'll deal with it then. Say in your 50s, so that doesn't leave you a lot of time. In your 50s, you save $500 for a year. $500 times 12. 500, instead of saving $100 a month, you're going to save $500 a month. You're really worried about it now. That gives you $6,000. Well, if you save $500 a month, all of your 50s, so for 10 years, that's only going to be what? $60,000. I asked you guys to start, this was with $200 a month. We even did this before with $100 a month and we were still a millionaire. If you save $500 a month, so you're starting with $60,000 at the same rate of 12%. How long is it going to take you to be a millionaire if you start saving in your 50s, even if you've saved $500 a month? This is my time. This is my A, or final amount. At 0, I'm at $60,000. After 10 years, starting with 60,000, 1, 2, 3. I'm only at what? 186. If I save it for another 20 years, I'm more than doubled how much I was saving, and it took me 20 years to get 578,000. I'm still not at $1 million. Or I could change, that would round up to an 8. After 30 years, finally, after 30 years, where am I? A millionaire. But how old am I? 90. Thank you, Justice. You're 90. So is this going to help? Your $1 million, you're going to have to start spending it way before it can turn into $1 million, right? Would you rather retire? This was at the end of our 60s. Saving $500 a month, we had $60,000. This was at the end of our 30s, our 40s, our 50s, our 60s. Would you rather have $719,000 to retire on? Or would you rather have $60,000 to retire on? I can't tell you. You're going to be sitting there one day. All of you are going to be sitting in HR one day. And someone's going to say, do you want to put any money away in these are our retirement account options. And I hope and pray that a little voice inside your head will be Miss Baker. I'll be singing the quadratic formula, and I'm going to be saying, all I asked for was $100 a month. If you put that $100 a month in the first time you start your job, and then you never look at it again, you will be a millionaire. You will be a millionaire. Think about it. All right. We have another formula that we need to look at. Please write this one down in your notes. We have A equals P times 1 plus R over N. And I know it's sometimes hard to tell the difference between my R over N to the NT. This one is a little bit different, Myra, because we are going to divide our rate by a number of times. The N is going to stand for the number of times per year we're going to compound the interest. What we were doing before, we were only compounding our interest once a year. So our A is still the final amount. The R is still our rate as a decimal. The N is going to be the number of times per year the interest is compounded. And the T is going to be our time in years. So I'm going to go ahead and stop here, and I'll